Hello, everyone. Welcome to another technical session from JUGBD. Today, we have a special guest, Reza Rahman. We'll be talk more about him for a minute. But before that, let me give you a context. Recently, I have seen a news that Microsoft depends it in investment in Java. So I got a little bit curious why Microsoft is doing this. So that's the one of the reason why we are going to have this session with Reza Rahman. I know many of you already know him. So he's one of the popular figure in Java community. He has been doing Java for like 25 years. It's a long time, and he worked in Oracle recently. Currently, he's currently working on Microsoft as a principal engineer. So we'll definitely know a lot about the this recent phenomenon, what Microsoft is doing in terms of Java and why they are doing. And this session is for that. So we'll definitely want to make it a little bit interactive. So if you have questions, let us know in the chat section, and we'll try to accommodate as much as possible. And yeah, so that would be wonderful. I think that we'll be able to know a lot of interesting fact why Microsoft is doing such investment in Java. So and to make it more interactive, let us know from where you are joining so that we can connect with you more. So thank you. Welcome, Rajaram. You are on mute.
Sure thing. Oh, all right, Buzler, thank you very much for that introduction. So I'll introduce myself a bit more, if you will, and
Sure.
also try to talk to you about what the presentation is about and what I'm going to be trying to do with it. And also, to be frank, this particular talk is special to me as well, and I'll explain a bit why that is. So first and foremost, as Baslu mentioned, my name is Reza Rahman. Basically, this talk is about what I do in my day job. In my day job, I'm principal program manager for Java on Azure. What that means is basically I'm responsible for product truth across the entire Azure platform when it comes to Java developers. So I work with a number of teams across Microsoft to do precisely that. And I also have sort of my own little team, and we work on something that I've been working with basically almost my entire career, and that is making sure that basically all the Java EE based runtimes are successful on Azure, and that includes things like the next generation Jakarta E platforms like Helidon and Quarkus as well. So that is also on a roadmap. We haven't really done anything with it quite yet, but we will very soon, and I'll talk a bit about that. So that's about me. What am I going to do in this presentation? So let me share with you where this presentation lives. It is actually publicly, the slide deck is publicly available. So let me go ahead and share that first. And I apologize, I should have gotten this out a little bit earlier, but it's morning. It's Saturday morning for me, so I'm kind of sort of awake still. So I'm going to post this in the chat. Let me see here. Comments show up. For some reason, I can't seem to be able to post comments. Is that right, Bazlur? Okay, so I'm not sure what's going on. I'm going to just post on the private chat. If you can do me a favor and just post that link in the public comments, that'll be great. Yeah, some destinations don't get comments. I'm not quite sure why that is. Doesn't matter. Okay. All right. So that's that. So what I'll be doing is it's mostly slideware. Okay, it's about, I'd say the most of the about 60 to 70% of the talk is slideware. I do have a little bit of a demo. I'll show you the demo in a bit, and basically gives you an experience of how Java development on the Azure platform looks like, and it is also sort of designed to be self-driven, right? So if you don't know anything about Azure, the intent here is you go to this GitHub link, which is in my private GitHub repo, and then basically go through that by yourself. It'll take you probably, I would say, plus or minus about 4 or 5 hours, maybe about 8 hours. But that'll also give you an idea of how how the Java development experience on Azure looks like. So if there is time, I'll do the demo. I may do the demo at the very end. What I'd also like you to do is, just because it's slideware, don't assume that I need to go through the entire material. I don't. I'm going to try to stay within that one plus or minus 1 hour time frame though. But what I prefer you do is actually ask me questions in real time. So whenever there's a question, you just go ahead and post it in the comments. I will stop and check the comments here every now and then. So I'll be just answering the questions as I go along, as opposed to doing them at the very end. Okay, so without further ado, let me begin sharing my screen. Hopefully that all works, and let's begin the presentation. All right, I'm gonna hide this little button here and minimize my window, minimize these windows, minimize that window, and there's a presentation. Do holler. I will if you can't see this, can't see the slide deck. Okay, and it is hot. I underestimated how hot this morning is. We're having a change of season now. We were in winter. Now we're gradually moving into spring. Let me know if you can see the screen. Okay, if that's the case, we need to fix it right away. But hopefully you can. Last I checked in the preview, you were able to see my screen.
We are all good.
Okay, great. So here's the title.
All right, there would be a little technical problem. We'll be back in a second. So we're currently streaming our YouTube, Facebook, and also over the LinkedIn. So whatever platform you feel like to join, please join us and share with your friends so that everyone can join us. This is going to be a really interesting talk, and I mean Microsoft have their own platform, right? .NET platforms and other platform. Why Microsoft is investing on Java? This is definitely a curious moment, right? I personally want to know a lot about this, so that's why we invited Reza Rahman, who is really celebrated personality in the Java community. So we'll definitely be able to know a lot of information related to Java, Java Enterprise Edition, Jakarta Edition recently that moved to and shipped to Eclipse Foundation. So I'm sure it will have plenty of questions about those things. So feel free to ask anything about those. And about the technical glitch, we'll definitely get back in a second. Don't worry about that, and let us know from where you are joining so that we can keep talking and this session gets interactive, and we get to know your opinion, we get to know your feelings, what you think about it, and what do you want to know about it. So let us know. We'll definitely make it more interactive. Let's see. I'll find whether I can. Let's see. I'm looking for the technical problems that we're having. We'll definitely get back. So the article that I was talking about. Okay. So all right.
Sorry, folks. I hope you can see me now. My machine began to hang for some reason. I hope it doesn't persist. But hopefully, I'm gonna reshare my screen, and hopefully, you'll be able to see everything okay. Yeah, my machine just hung altogether. So the only thing I could do.
All right. We're good. I think we can see your screen now. Perfect.
Okay. Hopefully that doesn't happen again, but we'll see. All right. So first, we should talk about why Java at all, and why is Microsoft investing in this. And to be honest with you, this is a graphic that I show even internally, and believe it or not, many people at Microsoft really still need to see this graph. Hopefully, all of you know what this graph is. This is basically one of the key programming indexes that we have in our industry. Frankly, there's not very many ways that you can reliably measure the impact of a language, but these language indexes are definitely a way. So as you can see, this is the long-term graph, right? So this is going back almost about 20 years. And the picture here is relatively stable, right? You can kind of see what is going on, what has been going on for a very long time. Is that you see there's two different classes of languages for the most part, right? So these are you see the most important ones, the two most important ones being Java and C++, whereas pretty much all of the rest of the languages fall in another category, and they have much less market share by comparison. Okay, so if you take a look at an even closer look at this graph, basically you'll see that things like Visual Basic and C#, where Microsoft's stronghold actually historically has been, those are not in the top at all. So Python is an exception. So Python has been rising in popularity since about 2018. But as you can see, Java still is very close to, it fluctuates a little bit between number 1 and number 3, depending on things like economic conditions. But really, if you look at the other bits of data in terms of what people use to write enterprise applications, Java very heavily dominates. Right? You'll see that picture if you look at things, for example, like job board postings and recruiter demand and the like. Right? Java usually almost consistently comes out number 1 there. So that gives you an even stronger picture of where Java is. So as you know, Microsoft is not so much these days about things like Windows and the like, right? The Windows SQL Server, MS Word. Really, majority of our business and a growing part of our business really comes from the cloud, and Azure being a very important component of that. So what that means is, if we want to be successful in the enterprise computing space, we need to be successful in Java. So all of our Java on Azure investment actually is basically a realization of that fact. Obviously, one of the other key things that has happened in making all of this happen is a change in leadership and a change in culture also. So I think you all know by now the culture change that has happened under Satya. And basically, Satya really brought Linux in the Azure platform. That is one of the key things that Satya did, and if you all remember. And that is really what powered Java on Azure. Without that happening, Java on Azure wouldn't really be that possible. So Java on Azure is not tremendously old yet. I would say Java on Azure is about a 5-year endeavor. I've been at it for almost a little over 3 years of that 5-year time span. So I've been doing this for a bit now, and obviously I am a key part of that effort in terms of Java on Azure success. This talk actually is something that has been delivered many times ago. This talk is the screenshot that you see is another person that is in our advocacy team now. His name is Brian Benz, and I believe this is a picture from DevOps France, 2014. So been quite a while now. Okay, so moving forward, what I want to do here is present this graphic to you. And this is a key slide for the presentation. What this slide sort of demonstrates is a roadmap of this particular talk, and in general, a high-level view of what Java on Azure actually is and what it is and what it is trying to do. So one thing that Microsoft realizes is that the Java ecosystem is not one monolithic thing, right? There's no one thing that makes you do this technology and okay, this is all you need to do in the Java ecosystem. That's really not the case, and that is a good thing. The diversity of the Java ecosystem has always been its strength. Without a competitive space where there's many different players and many different types of offerings, the Java ecosystem would not nearly be as healthy. So we know that there are 3 different segments, at least 3 different main segments in the Java ecosystem, and that is Java SE, or standard Java, and there's a smaller number of people that are using just standard Java and nothing else. And then you have Java EE or Jakarta EE or J2EE. Hopefully you're not calling it J2EE anymore. It's a name that's been obsoleted for almost 10 years. And we know that about between a quarter and a third of the workloads, and definitely we see this in Azure, and sometimes on Azure it's as much as, depending on what sample we take, it's almost as much as high as 50% of the workloads actually have to do with Java E and Jakarta E runtimes. And then you have the Spring ecosystem. And again, looking at the data we have from our customers, as well as the industry data, that's about, let's say, 60 to 70% of the data of the developers that are using that. And it depending on how you look at the data and what snapshot. Again, sometimes it's as low as 50%, but certainly 60 to 70% is a reliable and fairly accurate estimate of what you see in terms of the Spring adoption in the ecosystem. So what we want to do is, wherever you may be, whatever type of tech stack that you may be using, and in many cases, the same company uses multiple tech stacks. That's a very common situation. We want to make sure that you can land on Azure in whatever way that you want, and whatever technology set that you want to be using when you do that. So first and foremost, there are multiple different classes of places where you can land on Azure. Okay, so first and foremost, there's virtual machines. We'll talk about a bit more of that in a moment. There's of course containers. Okay, container-based platforms. Then there's managed services, and this is basically, you're not dealing with the infrastructure at all. You're just dealing with the deployment. Okay, so it's a database, you're just dealing with SQL. If it's a Java application, you're either dealing with just a jar or a WAR file or an EAR file, and that's it. You're not doing the OS installation, OS maintenance. That all is done for you. That would be managed services. And finally, on the bleeding edge, if you will, there's serverless platforms, and Microsoft has one of those, and we want to make sure you're enabled there also. We actually have a few serverless customers these days that are beginning to explore Quarkus. So it's a very interesting. That's a very interesting combination to look at. Now, as you can see, whatever pathway you may choose here, you have a rich set of features, right? So it's feature option rich, right? So it's up to you where you want to go, or even if whatever pathway you want to choose and whatever software you may be using on that particular pathway, we want to make sure to enable all of those for you. Okay, so let's go ahead and start our journey along this map. So we'll. The other thing I should mention is we in particular are not very opinionated about what your architecture should be. Okay, so we want to make sure we support all different types of architectures. If it's a monolith, bring it, no problem. You want to containerize your monolith, that's also perfectly okay. You want to do some combination of monoliths and new microservices, okay with that. Are you in the process of moving from monoliths to microservices, and you're trying to extract out part of your monolith into microservices? We want to make sure you're well supported. You're gone full-blown microservices and you have dozens of those, also welcome. Okay, so just like we don't care about the technology set, we also don't care about the architecture per se. We want to make sure all of these architectures are well enabled on Azure. Okay, so let's begin our tour of the different pathways to Azure. So we'll get started with virtual machines. Virtual machines are really nothing much more than I like to say, your data center on somebody else, your machine on somebody else's data center. That's really all it is. Fundamentally, really what you get is a virtual machine. When you have a virtual machine, it looks very much like, okay, this is your own desktop computer, or it's a virtual machine sitting on your own data center versus Azure. It's basically all the same. This is the most mature pathway of moving to the cloud and the most familiar one. So if you're not very familiar with the cloud, or alternatively, if you happen to be very, very cost conscious, because this is an older technology, it's also the cheapest. Okay, so virtual machines is your entryway into the cloud, if you will. So this is, like I said, what a key to this is the fact that Azure supports all kinds of operating system based virtual machines. It's not just about Windows. It used to be called Windows Azure. Okay, so it used to support only Windows, but that's definitely not the case anymore. I would say close to 50% of our workloads now is non-Windows, right? It's using one of these flavors of Linux. The most popular one on Azure, for whatever the reason, happens to be Red Hat. But other than Red Hat, we actually support a whole host of other operating systems as well, including more exotic things like Oracle Linux, for example. So in addition to providing your base virtual machines, cloud platforms actually do more with that. So even if you use this very simple technology, we can improve your experience. And one of the ways we improve your experience is by providing you what is called a marketplace solution template. So if you're familiar with Docker and Kubernetes, it's similar to that. It's basically a pre-built opinion on how you should be deploying a particular given software. So literally, each of these marketplace solution templates are little wizards that you can launch from your Azure portal, and these will basically allow you to say, okay, I want X, Y, and Z, and then once you go through those steps, it'll do the actual deployment for you. So it'll take care of all of the low-level details, and finally you get sort of working software. So you can say things like, yeah, I really want a 5-node WebLogic cluster. Please set all that up for me. So that is what the Azure Marketplace solution templates do, and we have a number of these basically targeting the Java ecosystem. So let's take a look at some of those. Okay, so this is a very small snapshot, very small snapshot. I'd say maybe 1% of what's on the Azure Marketplace portfolio to show you what you have for a Java developer. So we have marketplace solution templates for Zulu, okay, Azul Zulu. We have ones for OpenJDK. In terms of Jakarta runtimes, we have marketplace solution templates for Tomcat, JBoss, WebLogic, and WebSphere. In fact, the JBoss, WebLogic, and WebSphere ones is the ones that are co-developed with my team and the corresponding vendor, so Red Hat, Oracle, and IBM. And definitely, we like to get feedback on those solution templates for WebLogic, JBoss AP, and Red Hat, or rather WebSphere in particular. Other than that, we have solution templates for all of the major databases, including the NoSQL databases and including things like Hadoop. And then we have a number of messaging-related solution templates also, starting from ActiveMQ all the way to something more exotic like RabbitMQ. And similar story for DevOps tools, right? So you can spin up Jenkins. Actually, we co-developed this solution template with CloudBees. So this is a solution template to deploy Jenkins. But even if you want Elastic, we also have a partnership with the Elastic company, and they have a solution template that will allow you to deploy Elastic on VMs. And similar story for Splunk. And it's not limited to that. So really, we have the broadest possible choices when it comes down to solution marketplace VM-based solution templates. Okay, so actually, let me stop for a moment and make sure you don't have any questions, because I've been going for a little while and looks like it's at least about 20 minutes, so I don't see the comments as of yet. Okay. All right. I don't see any questions as of yet. Let me remind you that feel free to ask questions as we go along. There's no need to wait until the very end. So another thing that we support is the so-called multi-cloud platforms. Okay, and there's two key ones really. One is Azure Red Hat OpenShift, and the other one is VMware Tanzu. We support these in slightly different ways. I'll explain the ways these are supported, but we do support both of these, and we do these in the same way that we do the Java work. We basically create partnerships with the corresponding vendors. So in case of Azure Red Hat OpenShift, we partner with Red Hat, and for VMware Tanzu, we partner with VMware. So both of these things really are just abstractions over Kubernetes. Now you might want to ask, why do you need such abstraction, and what is the use case behind it? So these multi-cloud platforms, because they make it very easy to run Kubernetes, one advantage over Kubernetes is that so you get better developer productivity. But more importantly, these abstractions allow you to have a abstraction over your where you are running these platforms exactly. Okay, so basically they allow you to sort of be location independent. So you could be running the same OpenShift interface on premise, on Azure, on AWS, and what have you. And basically, what that allows you to do is move from one cloud to the other a little bit easier. Maybe use multiple clouds using the same underlying basic interface, or even make it easy to have some part of your workload on the cloud and some of it on premise and still use the same interfaces. They're reasonably popular. I wouldn't say they are by far virtual machines is the most popular, believe it or not, although despite its age, the most popular way of deploying to Azure still. Same thing, I think, with Amazon too. EC2 still remains their most popular service. Same with us. But there is some customers that do use these multi-cloud platforms. So Azure Red Hat OpenShift, we support that as a PaaS. So there's basically a managed service that allows you to get spun up on with OpenShift very easily on Azure. VMware Tanzu, there's a couple of different ways we support that. We don't have a first-party plain service that just runs VMware Tanzu, but what we do have is these marketplace solution templates that make it easy to run VMware Tanzu. And we have another little service that's called the Spring Cloud Service. I'll talk about that in a moment. And basically, VMware Tanzu support is baked into that service. Okay, so that's basically the couple of ways that we support VMware Tanzu. All right, moving forward, definitely containers is huge on Azure. Containers is, I would say, the fastest growing segment we have. It's not as big as virtual machines yet, but we can see that it will get there, right? Because it is just so such huge growth in terms of demand for running things in containers. So we want to make sure we're aligned with that, and actually we have made sure that for a very long time now. So we have one of the major three Kubernetes distributions out there called the Azure Kubernetes Service, and this is basically again a PaaS, right? So you don't have to set up Kubernetes; you just go into the portal, you go through a wizard just like you do for the marketplace solution templates, and then you have out on the other end is like you have a managed version of Kubernetes, Kubernetes up and running for you. So that is the crux of that is the key part of our container-based strategy. Okay, but other than that, we also have supporting services to Azure Kubernetes Service. One of the key ones being the Azure Container Registry. So when you're developing Kubernetes-based applications, you often will need a registry of some kind, and ideally a private one if you're a corporation. So basically, Azure Container Registry has very close tie-ins into the Azure Kubernetes Service, and it's secure and private and scalable. Now, the other interesting thing that has happened in the container space is we observed that not all applications actually need the level of orchestration that comes with Kubernetes or AKS. So there, in some cases, people just want to, they just have their Docker image, they have the container image, and they just want to deploy a single instance of it and then scale up and scale down those instances. So there isn't like a sort of closely interrelated set of services, if you will. So in order to facilitate that case, we've actually introduced something very new, and this is still in beta, and that is called Azure Container Apps. Okay, so in Azure Container Apps, we basically allow you to just deploy a Docker image, not have to deal with or even understand Kubernetes, and basically deploy a single instance of an application and again scale it up and down. So similar to virtual machines, we are actually creating marketplace solution templates that makes it easy, okay, to deploy to Azure Kubernetes Service in particular for now. We have support right now to do that for both WebLogic and WebSphere. or rather not WebSphere, but really Open Liberty and WebSphere Liberty. So we have marketplace solution templates that make it easy to do those. Down the line, hopefully we'll be doing the same thing for JBoss CAP. We will see. It depends on your feedback of what you would like to see. But other than that, we also make sure that all of the important artifacts, things like operators and Docker images and Helm charts, those are all certified, right? So we work with the corresponding vendors like Oracle and IBM to make sure all of those artifacts actually work properly on Azure. So you don't have to worry whether those things will work or not. And we also provide, in some cases, how-to guides on how to get started with these pathways. So we do quite a bit above and beyond just providing you these services. We actually try to make it as easy as possible to use these services.
So we have a questions
Yeah.
from Omid Chen. What he's saying is, how does Microsoft Azure handle the cold start problem for a static language like Java on service like Azure Function?
Let's talk about that when we get to the Azure Functions part.
Okay, sure.
It's a little bit premature still. So let me give people, the folks that are not familiar with serverless and Azure Functions, let me first give them an introduction of what we do there and what it is. Then I'll explain the cold start.
Sure. There is another question. Do you want to take that?
Yeah, please.
So the question Asad John Asad asked, beside the containerized Azure support, is there any kind of service mesh capability out of the box?
So not service mesh out of the box right now. So we are thinking of basically there's a couple of different service mesh ideas that are sort of in incubation right at this moment. Obviously, you can run HTO on AKS without a problem, right? So you'll basically have to self-service to do that. And as you know, that is really the most popular service mesh right at this moment in the industry. So we are debating whether or not to either bake in HTO support into AKS or have a separate HTO on Azure service. But we actually have another service mesh concept that we have sort of our own take on HTO. So that may be what we focus on for a while. So I think the answer is there are certain things we are thinking about, but right at this moment, really it's sort of self-service. Right? So you can definitely run HTO, and definitely a lot of people are already running HTO on AKS. So we know that is doable. Down the line, we may consider either baking that into AKS or basically having an HTO as HTO on Azure service. Okay, so if you tell me, so we talked about virtual machines and Kubernetes and the like, but in all reality, most of the major platforms support those, right? So if you go to Google or AWS, they'll tell you the same thing. Yeah, we have virtual machines. Yeah, we have support for Kubernetes, and yeah, we have the other two big distributions of Kubernetes really is the one from Amazon and the other from Google. But really, what makes Azure special and where we have really a stronghold and a unique value proposition, when it comes to managed services. Okay, so if you are a PaaS first shop, Azure, frankly, is a really good place to be, even if you are a Java shop, right? And we'll talk about that in a moment. I think the type of services that we offer for Java developers is also unique to us. Okay, so there's a couple of different variants of PaaS that we provide. One is PaaS platforms that are specifically geared towards Java developers. And the other thing we do is that we make sure that whatever our own best of breed software is, or stuff where we do not have an analog, but we believe is popular software, like Prometheus, Grafana, HTO, we have managed versions of those. Okay, so those are best of breed software that are not Java per se. Those are available as PaaS services, But then in that case, we make sure that we have Java bindings and different kinds of Java bindings for each of those bits of software, other than services that are very clearly very Java focused. So this is again a very small snapshot, but not that small. I would say this is covering at least 50% of our Azure application services portfolio. And you can see what the landscape sort of looks like. So our premier PaaS platform on Azure is called App Service. Okay, so if you talk to Java developers, rather .NET developers, that's what they're using. You can almost guarantee that they're using App Service, okay, for their .NET applications. So App Service now supports Java and pretty much all variants of Java. So we have a managed service for Java SE that uses Microsoft OpenJDK under the hood. I'll talk about Microsoft OpenJDK in a moment. We also have a Tomcat-based PaaS, and we also have a JBoss EAP-based PaaS. Okay, so if you want to run your Java EE application, you don't have to do anything. You just have to say, I want X amount of JBoss EAP and just deploy my year file or war file. So you can do that on Azure, and no other major public cloud can say that. Okay, that we can do that for Java applications, is be able to run whether it's Java SE or Tomcat or Java EE, you can do it. In fact, we also have a Spring-based service as well. I'll talk about that in the next slide. So aside from that, everything else, and this is, I have to be honest with you, there's some demarcation of people in terms of when they go to run apps, whether they go to VMs or app service or Kubernetes or what have you. But by and large, aside from that, when people are running other bits of software, it's a very good bet on Azure that they're most likely using some kind of PaaS-based offering. Okay, so this is especially true of things like databases. So we support all of the major databases except for Oracle as PaaS platforms. So we have support for Azure SQL, we have PostgreSQL running as a PaaS service, we have MySQL, and even things like MariaDB. These are all, you don't have to do VMs or on any of these things anymore. You can just rely on PaaS services to do that. Same thing for NoSQL. Okay, so our premier tier NoSQL offering is Cosmos DB, and this is even worth having a talk on its own. But basically, Cosmos DB is interesting. So it is basically a generic NoSQL service that supports different kinds of APIs. So it supports a MongoDB API, or a Cassandra API, or a Gremlin API. So as far as you're concerned, you're running Cassandra, or you're running MongoDB, or you're running Gremlin based API. But under the hood, it's actually running Cosmos DB. Similarly, we support Redis as a first-party service. This is an example of something that's not a Microsoft service, not a Microsoft software, but we have a PaaS platform for it. Same thing, by the way, for MySQL and PostgreSQL. That's not Microsoft software. But because these are best-of-breed software, we offer PaaS platforms on them. So GitHub Actions, I think you all know about this. GitHub Actions is basically our answer to CI/CD. So it has basically very close native integration and alignment with Azure. GitHub Actions, of course, is not specific to Azure, but it has very close alignment with Azure. A lot of our customers are beginning to use GitHub Actions for their CI/CD. The other part of it is monitoring and observability, right? So things like things you guys are probably using Splunk or Elk for. So the analog of that on Azure is something called App Insights. Okay, so this comes from the .NET family, basically, .NET ecosystem, but it's very similar. I'll show you a bit of App Insights in the demo. The capabilities are very similar to things like Elk. Aside from that, we have different messaging platforms. So one of the things I'd like to point out is Azure Service Bus. So Azure Service Bus, in addition to other variants of Java APIs, it also supports JMS. Okay, so you don't have to be running ActiveMQ on VMs and the like. You can just spin up Azure Service Bus and you have a JMS provider you can connect to. Same thing for things like blob storage, Azure Key Vault, Azure Configuration Service, Azure Active Directory, and a whole host of other things that are geared towards infrastructure, parts of infrastructure. So in these other ones, so things like the database, Cosmos, Service Bus, we make sure that although these are not Java software per se, we make sure that they work well with Java applications. And the way we do that is we make sure that each of these have service bindings. So typically, each of these services will have at least 3 Java APIs. One will be a Java SE API, so a proprietary, their own API, okay, that is Java based. If you don't mind being bound to a particular Microsoft based Java API, you can use that. Above and beyond that, if there is a Jakarta EE API that it can bind to, JMS is a good example of that. It will support that, right? It will say, okay, yeah, I also support Azure Service Bus. Same thing with Redis. It'll say, yeah, I also support Jcache. You can talk to me in Jcache, and it's okay. Now, above and beyond that, we also have Spring-based APIs. Okay, so if you're using Spring Boot and you're looking for a starter for each of these APIs, those are also available to you. So whatever pathway, wherever you are in the Java ecosystem, you want to make sure you're able to consume these services in an easy way. Okay, so finally, I do want to spend some time talking about Azure Spring Cloud. So Azure Spring Cloud is basically our PaaS platform for Spring developers. Okay, and again, it's unique. There's nobody else that has a first-party service that is geared directly towards Spring developers. So what this does is that it allows you to deploy Spring Boot applications for sure, right? At the bare minimum, this is what you can do: is you have your Spring Boot application. You don't have to spin up anything. You can spin up Azure Spring Cloud and say, "Hey, deploy my Spring Boot app." Above and beyond that, though, what we also do in case of Azure Spring Cloud is Spring. You've hopefully heard of the Spring Cloud components. So normally you would have to spin those up and manage them yourself. So with Azure Spring Cloud, you don't need to do that because it's already done for you. Right? So it's already running. So you can just depend on those APIs being there and be able to use it directly in a managed fashion. So whether that's a API gateway or a config dashboard or circuit breaker or service registry or distributed tracing, what have you, it's already running. The analog of this, in case you are a microprofile or a Quarkus developer, is that actually for each of these things, there's either an Azure answer or a Kubernetes-based answer. So actually, even if you're running Spring Boot, you can think of it in the same way. So you could be running Spring Boot, for example, or Quarkus on AKS and be able to use other things other than Spring Cloud components. So for a circuit breaker dashboard, for example, you could be using things like Grafana or Zipkin. You could be used for API gateways. You could be using Azure API IM or Azure API management, or things like Azure Load Balancer or Azure App Gateway. For config, there is a specialized service for in Azure called Azure Key Vault or Azure App Configuration Service. Similarly, for distributed tracing, again, you could be using Zipkin. For service registry, it's typically built into the Kubernetes platform. So for each of these, there's many different ways of slicing and dicing it. But Azure Spring Cloud basically gives you everything in a box, right? It's already all up and running and managed on your behalf. Okay. So there was a question on serverless. So let me begin talking about serverless. So a smaller segment of our customer base does use serverless. They tend to use serverless for specific use cases rather than necessarily as an answer to all of their enterprise applications. They use it for certain use cases. So we do have a serverless platform on Azure. We've had it for a while now. It's not as popular as the one on AWS, which is Lambda. Most people, when they think of serverless, they're thinking about Lambda. But we do have an analog to that, and that is called functions. And basically, think of serverless or functions as sort of method as a service. Okay, so you deploy one thing that you do, say a single the logic for a single API endpoint, single REST endpoint, or a single messaging endpoint, and it gets triggered in some way, right? Either it's through either an HTTP invocation or some database trigger, some database insert, or a message in Azure Service Bus and the like. So it's that basically. It's business logic as a service. It has some advantages, in terms of being not having being very light on infrastructure, and also if you have something that isn't used very often and it's only invoked every now and then, it provides some cost advantages also, because it is basically pay as you go, right? You're getting paid per invocation as opposed to paying for dedicated software. Okay, so there was a question around cold start and Azure Functions. So we basically do a few things to mitigate that. Ultimately, you will there is the reality of cold start. So frankly, if you're first and foremost, to be very honest, if you're using serverless, you need to be using a framework that is a Java framework that understands that problem. So I'll be honest with you, the best Spring Boot does not do so well here, at least not yet. The Spring folks are working on something like something called Spring Native that's going to understand that problem better. But there are other bits of other solutions in the Java ecosystem that have already matured that problem. So these are things like Micronaut, Quarkus, and Helidon. Okay, these, I would say, if you're developing serverless applications today on Java, that's the first thing you need to be really looking at. Is you need to be looking at Graal VM, and you need to be looking at things like either Micronaut, Quarkus, or Helidon. Quarkus probably being the most popular one. So above and beyond that, if there's a few things we do. One of the things we do is we have this called function pools. So you can define you can say that, okay, please keep a pool of 10 of these instances. So we do not basically create instances and throw them away. We create instances and keep them warm for you. So that can reduce, first and foremost, the cold start aspect a little bit. We also provide pooled resources. So if you have a MongoDB connection, or you have a connection to Azure Service Bus or what have you, all of those we can allow you to pool and just simply refer to those connections declaratively in your Azure Functions. So that helps with the cold start as well. And finally, Azure Functions has different plans. So one of the plans is what's called Azure Functions App Service Plan. And what you do there is that you just have dedicated hardware, dedicated infrastructure attached to a particular Azure function. And that's basically the equivalent, honestly, of just creating the Azure function and deploying it, and it is just there for you. So that will eliminate the cold start problem altogether. But sorry, you're back into the billing model of same billing model that you have for VMs or app service or Kubernetes, in that you are paying for dedicated infrastructure. So aside from Azure Functions, which allows you to sort of code as a service or a method as a service, we also provide another thing called Logic Apps. Right? And well, Logic Apps basically is a codeless or low-code platform that allows you to wire together different Azure functions. So if you're doing things like simple switch operations, you think of it as a sort of the enterprise integration patterns, or ESBs. So it's sort of like ESB of the serverless age. Right? It has built in some logic patterns built into it. That's why it's called Logic Apps. Okay, so I do want to spend a little bit of time talking about the Microsoft build of OpenJDK. So believe it or not, Microsoft has its own build, has its own Java build these days. And this is the Java build that's actually baked into Azure. So all of the Azure services that have anything to do with Java, whether that's running JBoss CAP or running Tomcat, running Azure Spring Cloud, all of that uses this internal build of OpenJDK in it. But other than that, this is actually freely available to you, right? So it's free, it's open source, and it is LTS compatible, which means we provide long-term support. much more long-term support than Oracle JDK does, for example, for all of the versions. Okay, and you can run it on Mac, Linux, or Windows. ARM, we're still M1 chip. It's still beta. It's still in early access mode. But majority of the other platforms you can run them. You can run the Microsoft Builder Open JDK. One thing I will note for you is that we do not support Java SE 8 at the moment. It's only Java SE 11 and upward. Okay, so we are providing even support for Java SE 17 at the moment. And this is all done actually, again, not just by us, but we do this by actually joining the Eclipse Foundation, the Adoptium project in particular. So the Adoptium, we do, our build is actually nothing much more in a sense of just another instance of an Eclipse Adoptium build. So that is the work that we're doing that has actually really not that much to do with Azure. So you can be running this wherever you want, but obviously it's baked into the Azure platform. So wherever we are have anything to do with Java, ultimately we're using the OpenJDK build.
There is a question regarding this. So question is, I mean, every vendor sort of adds some secret sauces to the OpenJDK distribution, right? So for this particular, I mean, Microsoft build, is there something like that? Or I know that recently Microsoft started contributing to the recipe heavily. And is there anything special to these, specific to this, Microsoft distribution?
Okay, so before I answer that, let me give you some history about Java and Microsoft. Okay, Microsoft stopped doing Java because of something legal problems around something called J#, and that was basically a Microsoft variant of Java. We definitely don't want to be going down the J# path again at all. Okay, we're trying very hard not to do anything even similar. So no, the answer is there is no secret sauce. This is pretty much what you would get if you were building OpenJDK yourself. We do obviously work on it to some extent. The ARM work is one of the examples of that. But our objective is not to keep that within our own build. Our objective is to, as much as possible, have parity with the plain old OpenJDK build. So whatever work we are doing, we actually try to make sure that we contribute back right away as soon as possible, so that in no cases should you really be doing anything specific to our distribution. So I would say our objective is open, as much openness as possible. So no, there's no secret sauce right now.
It's more of a maintenance, right? You're going to support the build for longer than LTS or other. So yeah, that makes sense.
Yeah.
All right.
Okay, so our story would not be complete unless we talked about a little bit about Azure tooling. All right, so as Microsoft, especially if you talk to a Microsoft .NET developer, they will tell you that the real strong point of .NET is not necessarily the language. Okay, the language is more or less equivalent to something like Java. The real value proposition is in tooling. So we want to make sure that story and that ethos is reflected when we talk about Java on Azure as well. So we support all of the major tools, or we have our own flavors of tools to support the Java ecosystem. So we have integrations with Maven. So most of our popular services, things like Spring Cloud Service and App Service, they all have Maven plugins. Azure itself has a Maven plugin that will allow you to deploy very easily from your CI/CD pipeline onto Azure. Similarly, we have extensions of Jenkins. Obviously, we're focusing much more on GitHub Actions, but we still do support Jenkins pipelines. And of course, we support things like Terraform. Terraform is vastly popular with Java developers as a way of doing deployment in a sort of code as infrastructure way. So we do make sure to support Terraform as well. So we have Terraform bindings for all of our major services. Again, things like AKS or what have you, they all have Terraform bindings. Above and beyond that, let's say none of these things are good enough for you, and you are a third-party developer that needs to talk to Azure directly, or you are developing some open source software that you need to do something with Azure directly. I would say the base currency for that is something called the Azure SDK. Okay, so even if you go to the portal or you're using the Azure CLI, ultimately all of those make invocations into the Azure SDK. So even that Azure SDK actually supports the Java. Okay, so it cannot get much more foundational than that in terms of how far down we actually go to support Java. Okay, we also have IDE support. So just like other cloud vendors, we have built-in tooling around IntelliJ and Eclipse, okay, for our major services. Aside from that, I hope some of you know about VS Code. So VS Code is actually Microsoft's sort of next generation IDE concept. Think of it as a lightweight editor. And we actually do quite a bit to support Java development on VS Code. So if you're using VS Code, you can do things like basic formatting, IntelliSense, color coding, debugging, Maven integration, JUnit integration, support for the popular Spring, Java E or microprofile APIs, whether it's Tomcat or Quarkus or Open Liberty, Western Liberty, or Pyara or Wildfly or JBoss AP. All of those are supported into VS Code. In addition to that, we also provide the same thing that we do for the other IDs, which is also support Azure. So there's a plugin, Azure plugin for VS Code that allows you to specifically interact with Azure services. So I hope you take a look at that. We believe it's an important entry into important contribution that we are doing into the Java tooling space with VS Code for Java. Okay, so I don't have a tremendous amount of time left anymore. Let me make sure that, give me 1 second here. And actually, never mind. I'll finish with the demo. Let me show you some of the examples. So let's put all of this together in a few examples. And these examples actually are inspired by real-world customers that are using Java on Azure. Okay, so here's an quick example. I'm going to run through this since I'm running low on time. So this is something that you can get out of the solution template. If you run the solution template for Oracle WebLogic Server, it'll get a WebLogic cluster up and running for you. Have built-in support for coherence. Again, you could be running Oracle database. We have a similar marketplace offering for Oracle databases, and you could be doing your deployment, let's say through GitHub and Jenkins using Maven, using Eclipse as your IDE. Same thing for, let's say you're wanting to run Kubernetes, and again, this is a actual deployment inspired by a customer, a Java on Azure customer. So if you want to, let's say, run Webster Liberty instances using the Open Liberty operator and Open Liberty Docker images, you can do that on Azure Kubernetes Service. We give you marketplace solution templates on how to do that, or step-by-step guidance. And beyond that, again, you could be using GitHub Actions and the Azure Container Registry in your CI/CD pipeline, and make use of all kinds of other services. We have built-in support for a more robust load balancer into Azure Kubernetes Service with App Gateway. So you could be using App Gateway as an example. Here's an example of using App Service. So if you want to do JBoss deployments, you can deploy your JBoss instances and just deploy your WAR file directly. And again, be able to have all of the underlying infrastructure in a Azure native way. Same thing for Azure Spring Cloud. We have a few customers on Azure Spring Cloud already, and they're doing something very similar to what you see in the picture here. Or if you happen to be using, let's say, Azure Functions, so you could be deploying Azure Functions. You can actually deploy Azure Functions directly from VS Code. We have a plugin that allow you to do that. And then you could have multiple different Azure Functions that talk to different backends, either Cosmos DB using NoSQL or Azure Service Bus, or even something like Twilio, which we also support on Azure Functions. And you could have that be pulling from something like blob storage where it's using sort of logic apps as a circuit breaker or a router to figure out which function is actually invoked. So I won't have time to do the demo today, but here's a link to the demo. So I'll show you the GitHub repo for it real quick, and show you what the intent here is. So if you've never done Java on Azure before, this is basically a working example of an application. You can go through this end to end, and you get a functioning Java application in the end that uses a number of different Azure services. I happen to be using Wildfly as my example here. So you could be using Managed SQL, and it gives you step-by-step instructions on how to do that. You could be using App Insights as basically your observability platform. You could be using Azure Cache for Redis, and that can be hooked up to be used as a second level JPA cache for Wildfly or Hibernate in particular. And then you could be running your application in VS Code. I actually have it running in VS Code right now. So here's my application in VS Code. Maybe if I just have a moment, I will show you how to do that. You could be setting it up all in Kubernetes. I actually have that up and running right now. And then you could be using GitHub Actions workflow to do the deployment. In fact, this is what happened. Right? So this is my actual build that I did with all of this. And as you can see, it's setting up Maven, setting up Java, and doing. So I actually have a application up and running right now. That is Java application up and running right now on Azure. That does all of the things that we talked about in theory. Okay, so moving back to my presentation, actually over time. So I encourage you to go into this GitHub URL and repository and take a look at it by yourself. And that'll give you a first-hand experience of how Java on Azure development actually looks like. Okay, so to summarize, Microsoft is very serious about Java. We understand that the Java ecosystem is diverse. Whatever your pathways and also whatever pathway you want to follow on Azure, we want to make sure you are well supported. Whatever you wind up choosing, whether it's virtual machines, container, managed services, serverless, or all of the above. And we also want to make sure that we have tooling available to do that. And we also want to make sure that we are good stewards of the Java ecosystem. That is really what the OpenJDK effort that we're doing, that's more or less what it's about. It does have Azure tie-ins, but beyond that, we're actually supporting the Java ecosystem actively by doing that. So here's some resources for you. You can take a look at that. If you want to find out more about the OpenJDK build, that's the URL for that. We have a Java on Azure landing page. If you want to learn more about Java on Azure, this is one place you want to go. Aside from my slide deck, which you are also welcome to use. And then you have the docs for Java on Azure, and you also have the code examples. So okay, I think that's about wraps it up. I'll just, I think for now, I'll stop sharing my screen since we're at the hour. And I'll take any last minute questions that you might have. Otherwise, I think
we'll have a few questions. I think more than a few. So I'll pick a few. I know we're out of we're top of the hour, but let's pick a few. I'll remove that and I'll pick those questions for you. So let's take the first question about. Abdullah Arno, he asked about that. For working with Kubernetes, OpenShift provides code-ready containers. It's called CRC for development, which makes it easy for developers to develop, test locally in the same way actual prod environment. Is there anything similar to Microsoft offering?
Yes. So there is something called Microsoft Code Spaces. So it basically allows you to develop. Mostly, it is based on VS Code. But more importantly, if you happen to be using CRC or you're using something like source to image, you can just use OpenShift on Azure. Right. So we do provide the Azure Red Hat OpenShift for that reason. So if you happen to be an OpenShift user, you can just continue to use exactly the OpenShift tooling that is provided by Red Hat. There's no reason to reinvent the wheel or look for any other alternatives for that. You can just
I have a follow-up question regarding this. I mean, OpenShift, they have their own cloud infrastructure, right? So, is there any advantage over, using? Let's say I use OpenShift and I want to use a cloud. Why not use their cloud provider instead of Microsoft? I mean, what is the advantage over here?
The biggest advantage is that we are a top-tier cloud provider. So we have many more data centers, a lot more stronger security certifications, and a lot more services. So even if you are using OpenShift, it's not like you're going to be limited to just using OpenShift, right? You're going to have to think about things like the bare minimum databases and other bits of infrastructure. So obviously, we will do much better there, than majority of other clouds. Azure actually has, just to give you an example, we have more data centers than any other cloud provider.
That's interesting.
Okay.
Okay, let me take for the next question. We have already talked about this, which is cold start of Java serverless app. Is there any do you know any startup time for Java app?
It depends on the Java app. It can be, if you're using something like Quarkus, it can be in the order of milliseconds, right?
Right.
But if you're trying to use like an old school Spring Boot app or an old school Tomcat app, you're talking about, it depends on what your app startup time is. It could be a few seconds, it could be up to a minute, right? Depending on what your cold start is there.
So the follow-up question is about Quarkus. Is it possible to talk about Quarkus? I mean, definitely it needs another presentation. So if you have a specific question, that would be better, I guess.
So Quarkus, we are a lot of our customers are expressing interest in Quarkus. If you notice, I didn't really directly mention Quarkus support in the presentation yet. It's because it's a very early stages yet. So we have started that conversation with Red Hat. And there are definitely customers that are already using Quarkus, and they're already telling us, hey, what are you doing for us? So we will be focusing on that work. Most likely, there's two things that will happen in the short term, not too far from now. One is that we will be writing guidance, to how to run Quarkus on something like AKS, for example. And the other thing we may be doing is adding, where it makes sense, some microprofile bindings to some of our APIs.
All right. So that's another question. It's a different question related to security policies. I mean, Azure supported OPA or Kubernetes or others. Please, is there anything regarding that security policies on Azure?
So this is a vast topic. You could go on for hours for this. Best thing to do is just Google Azure and security. We have, like, honestly, crazy amounts of security certifications and security policies. Like Azure, I think it may be the most secure cloud platform out there. But yeah, just Google Azure security. You'll land on an Azure Docs page. It'll tell you more than you need to know about security and Azure.
All right, I'll take one or two more questions. So this question by Said Hassan. So what he's saying is Jakarta is being developed under Eclipse, and also Microprofile is one of their framework. How likely is it to see Microprofile as a de facto practice to develop microservice with Jakarta EE?
So going forward, the applications that we have that are running Java EE or Jakarta EE and Azure, they broadly fall under two different categories. One is actually existing applications. So these are applications that have been running for 5, 10, in some cases 20 years. They are largely Java E6, Java E7, Java E8 applications. Those are, I would say, probably are in the 60 to 70% of the applications that we see in terms of Azure. There are sort of a smaller portion, I would say somewhere between 15 to 25% of applications that are net new applications. These are not Java EE. They're at least Java E8. In some cases, they are Jakarta E8. Hopefully down the line, we'll begin to see Jakarta E9 applications. We haven't seen any of those yet, but definitely we've seen Jakarta E8 applications. And these applications are most of the time cloud native. So they're using something like Wildfly bootable jars or Open Liberty that supports very high levels of modularization and even sort of layered, supporting bootable jars in a layered Docker and Kubernetes friendly way. We rarely see those applications being purely Jakarta applications. They most likely they're using some kind of microfile APIs, even if it's something very simple like microfile health or microfile metrics. So I think going forward, it's going to be rare to see just a pure Jakarta application. More and more, what we see in terms of the Jakarta applications is applications that use both, both microprofile and Jakarta.
Great. So we have a few comments. I'll just quickly go over them. Hey Max, nice to see you here. What he says is Reza Rahman, Bozdur Rahman, both of them has Rahman at the last name. So that's interesting combination.
It's a super common last name, just so you know. One of the most common last names in some parts of the world.
All right. So there is a few other comments. Nice discussions. Thanks, Raja and Bozdur for your effort. Okay, thank you. So there's one last controversial question. I'll take that as a last question, which is it possible that in any future C# will be ported for JVM?
C# will put not very much value proposition, to be honest, right? So you know about Mono, right? So Mono basically allows you to run C# .NET applications in non-Windows platforms. So primarily target being Linux. Whether it makes sense to support C# in the JVM, I don't know that there's a value proposition, honestly. What would you gain from that? .NET already has very good management in terms of the equivalent of what we do in the Java ecosystem. So they've had a VM for a while. Their VM is pretty performant. Doing all of that and reinventing the wheel just to say it's running on a JVM, I don't know what the value is, right? But we're open to feedback. Right? If there is a strong use case for it, let us know, and then we'll investigate it.
You mentioned about GuardVM in your talk once. So GuardVM support plenty of other languages like JavaScript, Python, and others, including Java, obviously. So in that regard, is there anything? GuardVM may think of another language. Can they support C# or any other language? Just an idea.
Let's talk about the use case. If there's a specific customer use case, we can talk about it. But you notice there is a distinction there, right? These languages don't have a VM of their own, VM technology of their own, versus something like C# does. So, it takes, frankly speaking, probably decades of effort to write a VM well, right? Abandoning that and saying, okay, let's do this on Graal, I don't see the value proposition.
All right. So that's all we have. And everyone thanks you for joining this session and giving us this valuable information and ideas. So thank you for we really thanks for your time from JUGBD, and personally I enjoyed your entire session. Thank you very much.
All right, my pleasure. And maybe I'm definitely open to coming back and speaking again with you guys.
All right, so we're closing now. Thank you everyone who joined us, and we'll probably have another session in pretty soon with another exciting topic. Thank you everyone. Bye bye.